Hello everyone. In today's video, which is AS Equilibria theory, which will be the last video of CAIE A-Level Chemistry AS Equilibrium. And in today's video, we'll be covering the recap of redox from your IGCSE, the redox rules, and a few practice questions from those to get you fresh in it. And lastly, which is the most important part of this lesson, is balancing equations using the oxidation numbers and like completing full equations from the given half equations. All right. Yeah, that's pretty much it. So let's get to it. So in first part of today's video, not the first part of today's lesson, we'll be learning what redox is. So from your IGCSE years, redox basically means reduction, oxidation, reaction, right? So a reaction in which both reduction and oxidation takes place. Yeah, that's pretty much it for redox. What redox is. And there are some important rules of redox reactions, rules, which you have to follow. Okay, and these are rules that you've covered also in your IGCSE years, but let's just have a recap of those rules. So firstly, oxidation number of any elements alone is 0. So for example, if you're given Cl2 or Mg, these alone have an oxidation number of 0. Okay. The second rule is that oxidation number of the ion equals its charge. So for instance, if I were to tell you Mg2 plus, the oxidation number of this would be 2 plus. Okay. The third rule is that the oxidation number of oxygen is always -2 unless a peroxide. This is important. So oxidation number of oxygen is always -2 unless it's in a peroxide, right? The fourth rule is that the oxidation number of hydrogen is always +1 unless metal hydrides. Like with NaH, this will be plus and this will be minus, right? The fifth rule is group 1 and 2 have oxidation numbers respective to their group. So Na would have the oxidation number of +1, right? And Mg would have the oxidation number of +2, right? In a compound. Not like the elements alone. And the last rule is that group 17, which is 7 halogens group, usually has -1 oxidation number. So MgCl2, the oxidation number of this is -1. Okay. Yeah, that's pretty much it. And one important thing, which is in relation to electronegativity from your chemical bonding lesson, if I'm not mistaken, is that the more electronegative atom gets the negative oxidation number. So for example, in HCl, right, Cl is more electronegative than H, so therefore Cl minus has the oxidation number of negative and H has the oxidation number of +1. Okay, that's pretty much it for the rules. Okay, so let's have a few examples. So for Cr2O7 2 minus, so find out the oxidation number of chromium. To find that out, you have to construct an algebraic equation. So 2x, x being the oxidation number of chromium, plus 7 times -2. So 7 times -2, which is ±14, right, is equal to -2, because that is the total oxidation number. So that'll be 2x is equal to, so that's minus 2 plus 14, that'll be 12, therefore x is equal to 6. So the oxidation number of chromium in this is 6. Let's do another example, MnOH2. You don't really have to construct like an equation for this, it's really obvious, but if you want to, I'll just tell you. So OH minus is negative 1, so negative 1 plus, alright, so this is x, right? X plus 2 times negative 1 is equal to 0 because the overall charge of the compound is 0. So you take this to that side and you get x is equal to 2. So the oxidation number of manganese here is 2. Let's do a slightly more difficult one. K2Cr2O7, nope, that is what we basically did. KMnO4, right? So what is the oxidation number of MnO4? Well, KMnO4, so this has plus 1, right? So let's just take the ion instead, KMnO4 minus, right? So x plus 4 times minus 2 is equal to minus 1. So x would be minus 1 plus 8, so 7. So the oxidation number of this is plus 7. Oh yeah, and for oxidation numbers you always have to write the plus or minus sign because you have to make it obvious, like what exactly is the oxidation number. Is it plus or is it minus? Because there's a possibility of both. So it's always better to write the charge, okay? So that is a small recap of redox with some practice equations. Now let's move on to the heart of this lesson in your A-level chemistry, and that is balancing redox, balancing equations, equations using redox, right? Okay, so let's say I gave you this equation, MnO2 plus Al gives you Mn plus Al2O3. Now how would you balance this equation, like without spending too much time on it? If I asked you to balance this equation, yes, by luck, maybe trial and error, you would get an answer like a perfectly balanced equation, but usually that trial and error takes too much time, right? So there's a perfect way of doing this, and that is by using redox, like finding out the changes in oxidation numbers. So how would you do it? So first find out the oxidation numbers of each in the reaction. So for oxygen it's always minus 2, right? And for manganese here it would be, because the charge is 0, so 0 plus 4, so it'll be plus 4, right? The manganese is plus 4. Aluminium is by itself, so that's 0. Manganese becomes 0 and aluminium becomes, so 2 into minus, right, 6 divided by 2, that is 3, so this becomes plus 3. Now you write down the changes in oxidation numbers. So for Mn, the change of oxidation number is from plus 4 to 0, right? So the change would be is equal to minus 4. It undergoes reduction, right? And for Al, it's from 0 to plus 3. So the change is 3 minus 0, which, so the change is plus 3. So it undergoes oxidation, right? And then you just cross multiply for Mn and Al. So Mn changes by minus 4 and Al changes by 3, right? So cross multiply, so you add 3 here, 4 here, and then when you add 4 here, you see that this is 4 divided by 2, so this will be 2, and Mn 3, right? And by that you just irrefutably balance this equation using redox. If you want to check whether it's perfectly balanced or not, you can go ahead and do that yourself, but I know for sure that this is perfectly balanced. But it's always good to make sure that it is perfectly balanced, because sometimes even after doing this you will have to do additional balancing, like additional work to balance it. So for instance, because there was 4, when you multiply Al with 4 you get 4 Al, right? The additional work I had to do is, because I wrote 4 here, I saw that there's 2 Al here, so it had to be something times 2 to give me 4 in total for the reaction to be perfectly balanced. So in this case I'd have to give it 2, and even when I gave it 2, you see that 3 times 2 is 6 oxygen, and over here 2 times 3 is 6 oxygen. That is the additional work that I had to do, but it was very minuscule, okay? So let's do that for, let's practice for some other equations, right? So HNO3 plus, what is that? H3ASO3, I believe that's astatine, which gives you NO plus H3ASO4 plus H2O. Go ahead and try balancing this out using the redox method. Feel free to pause the video. Anyway, we will attempt. So for H, you know that it's always +1, and for oxygen, it's -2. So 2 times minus 2 times 3, right? So -2 times 3 plus 1. And -5 is left over. The compound has 0 overall charge, so therefore the oxidation number of nitrogen must be +5. This is again +1, and this is -2, so minus 2 times 3 plus 3, right? And -3, and the oxidation number of astatine is over here +3. Now let's see how it changes. So NO, this -2, and because this -2, this will be +2, right? And in this case, so it'll be -2 times 4 plus 3. So the oxidation number of astatine changes to +5, and well, this is +1 and -2, so this is really irrelevant. So you see that two compounds are undergoing oxidation and reduction. That's nitrogen and astatine. So you write that down, right? Nitrogen and astatine. So for nitrogen, it changes from +5 to +2, and therefore the change is equal to 2 minus 5, that's -3. So it undergoes reduction. Whereas for astatine, it changes from +3 to +5, right? So the change is +2, so it's an oxidation. And then you cross multiply, right? AS, it changes by -3, and this changes by 2. Cross multiply, and then you multiply each side. So AS would be by 2, right? No, wait, my mistake. AS would be by 2, and no, wait, sorry, no, AS would be by 3, and nitrogen would be by 2, right? So that balances this out, right? So 2, 3, have to do no additional balancing. Check the number of nitrogen. 2 here, 3, 9, 11. So 3, 9 plus 2, 11. Okay, so this is perfectly balanced, right? Sorry, this is perfectly balanced, right? If you want to, feel free to go ahead and check it yourself. Okay, let's do another example, because some of you may still not have the concept well sunk into your head. This is a rather difficult one, so let's get to it. Cr2O72 minus plus NO2 plus H plus gives Cr3 plus NO3 minus plus H2O. Go ahead and attempt this. So we did it before, so this would be +6, right? Cr would be +6 if I'm not mistaken. Just let me confirm. Yes, so Cr would be +6, and this would be -2, right? As always. Nitrogen over here would be +4, whereas oxygen would be -2, and this would be +1. H plus is, well, always 1, right? And Cr3 plus, well, it's given, so +3. NO3 minus, so -2 times 3, and -1 times -1 minus 6, so that's +5, right? So +5 is for nitrogen, and this we just keep it as it is. So the two compounds that are undergoing oxidation and reduction are chromium and nitrogen, right? So we find out the differences. So for chromium, it changes from +6 to, it changes to +3. So the change is -3, right? So it's a reduction. And for nitrogen, it's from +4 to +5. So the change is +1, and therefore it's an oxidation. So you cross multiply CrN, right? So this is -3, this is +1. So you cross multiply. So Cr times 1, so Cr you remain as 1. And nitrogen is 3, right? So 3 times the nitrogen, 3. But you realize here that there's 2 Cr here where there's 1 Cr here. So the additional thing that you have to do is add you add a 2 here, right? 2. Now we know that the number of nitrogen and the number of chromium are perfectly balanced, but the number of oxygen and hydrogen we do not know completely yet. So you find out the number of oxygen and hydrogen on each side. Well, in this side there's 7 oxygen plus 3 plus 3, 6. So 7 plus 6, that's 13, right? So 13 oxygen on the left hand side, whereas on the right hand side we only have 9 oxygen. So how do we get to 13? So that would be 4, right? So 4 plus 9 would give you 13. So you have 4 more oxygen on the right hand side. Now oxygen is perfectly balanced. Now the only thing that's unbalanced is hydrogen. So on the right hand side we have 8 hydrogen, whereas on the left hand side we only have 1 hydrogen. So so that'll be 8, right? 1 times 8 will give you 8. So that is now perfectly balanced. Over here we had to do a bit more additional work, but yeah, you just have to, just to be sure. Let's do one more example, okay? This one, I'd like you to actually pause the video and give an attempt yourself. S2O3 2 minus plus H2O gives Cl minus plus SO4 2 minus plus H plus. So I'd like you to give an attempt yourself, just to test whether you've actually understood the concept or not. Also, the examples that we're doing here are more complicated than the past paper questions in AS, so rest assured, in the AS part it's a lot easier, but in A2 it can be a bit more complicated, but we'll cover that when we have to cover it, right? So first off, we find out the oxidation number. Cl is 0 here. S2 would be plus 2, and this would be minus 2, right? And H2O, well, we just leave it as it is because it's not really that relevant. Cl becomes Cl minus 1. This is minus 2, right? So it'll be plus 6, and this will be plus 1, right? So the two things that actually undergo changes in this equation, or in this reaction, is chlorine and sulfur. So we write down Cl and sulfur, right? So chlorine changes from 0 to minus 1. Therefore, the change is equal to minus 1 minus 0, so that's minus 1, right? So it undergoes reduction. Whereas sulfur, it changes from plus 2 to plus 6. The change is plus 4, so it undergoes oxidation. So Cl and sulfur, right? Cl minus 1, sulfur 4, right? And then you cross multiply between this and this. So sulfur 4, right? So 4 becomes 4 here. So 4 times sulfur, no, sorry, sulfur doesn't become 4. Chlorine becomes 4, right? So 4 chlorine, so that's 2, right? And there's 2 sulfur here, so 2, right? And now we have to check the number of oxygen and the number of H plus. So the number of oxygen on the left hand side is currently 3 plus 4, whereas the number of oxygen on the right hand side is 8. So there has to be 4 more oxygen here, so 4 more on the left hand side. Now the number of oxygen is balanced. Now we just have to balance the number of hydrogen. There's 8 hydrogen here, but there's 1 here, so 8. And yeah, that's pretty much it. The place where we actually practically applied this was when we reacted sodium hydroxide, hot sodium hydroxide with chlorine. So Cl2 plus NaOH, which gave NaCl plus NaClO3 plus H2O, if I remember correctly. Was that the equation? I believe so. Yeah, that was the equation. So now try balancing this with using the redox equation. Like before, I asked you to memorize it because it saves more time, but try and solving this now. Well, I hope you've given an attempt at the question yourself. If you haven't, let's attempt at it together, and I'll show you how it's done. Okay. Well, you see that first you write down the ionic form of this equation. So that's Cl2 plus OH minus gives you Cl minus plus ClO3 minus, right, plus H2O. That is the ionic form of this. So you write down 0, right, and then this, and this is a disproportionation reaction, so minus 1, and then in this case minus 2, so that's minus 2 times 3, minus 1 minus answer, that's plus 5, right? So in this case, chlorine gets multiplied by itself. This is a bit complicated, right? So in this case, chlorine undergoes both oxidation and reduction, a disproportionation reaction. So it changes from 0 to negative 1. Therefore, change is equal to minus 1, reduction. And then it also changes from 0 to plus 5. Change is equal to plus 5, oxidation. Right? So 5 Cl 5 minus 1. So minus 1 times Cl, minus 5 times Cl. So which exactly do you multiply? So you see the Cl that has a minus 1, you multiply it with 5. Right? And the Cl that has 5, you multiply it with minus 1. So this remains as 1. Right? And now you balance the rest of the equation. So there's 5, 6, so 6 Cl. So 6 divided by 2, that's 3 Cl, right? Now you basically balance out the number of hydrogen and the number of oxygen. So there's 2 hydrogen here, and there's only 1 oxygen here. So you have to find a way to balance out the 2 hydrogen and 1 oxygen in a perfect manner. So in this case, that would be 3, right? So 3 times 2 is 6, and there's 3 oxygen. Whereas 3 oxygen plus 3 more here, and over here there would be 6. Okay, that is the way you balance this reaction with the like chlorine disproportionation with hot alkali, right? The last part of this lesson is calculating or balancing equations using the redox method. Okay, like you'll be provided with half equations and you basically have to balance the equation. This is very important in electrochemistry of your A2, so we will cover more of it then, but it has appeared once, not the electrochemistry, but like it has appeared once where you had to like find the actual equation from the redox and oxidation. So I'll give you an example like the one that came. So MnO4 minus plus 8H plus 5E minus gives Mn2 plus 4H2O and Fe2 plus, which gives Fe3 plus E minus. Okay, now in your electrochemistry it's a lot easier to identify which undergoes reduction, which undergoes oxidation because of this value, right? But I'll just tell you for now that this undergoes oxidation and this undergoes reduction. Okay, so if this undergoes reduction, what you have to do is you have to balance. So there's 5 electrons here, but there's only 1 electron here. So you have to make it so that there's 5 electrons here, 5 electrons here, and then 5 here. Okay, and because this undergoes reduction, you have to make this the subject of the equation. So 5E minus is equal to 5 Fe2 plus, no, not plus, it's minus 5 Fe3 plus. Okay, now you see that this is what 5E minus equals to, so you just substitute that into this equation, MnO4 minus plus 8H plus, right, 8H plus, and what's it equal to? 5Fe2 plus 5Fe2 plus, and because this is in minus, you have to take it to the product side. So Mn2 plus 4H2O, and the minus you have to make it plus, so 5Fe3 plus. This is the full equation, that's like the actual equation from the reduction and oxidation reaction. That is all for your AS Equilibria. If you understood, please leave a like and subscribe to the video and share it with those who may need it. And if you do have any doubts, please leave them in the comment section below.